I have a lot of material in the decks. I will not be able to squeeze everything in 15 minutes, so at least you have the PDF. I will try to spontaneously go through what I feel like is the most important, and in the end, in the questions, you can make me go back if you want to whatever I skipped. So, FHIR conversion made easy, hopefully. That's the goal. I want to show you some of the uses of an open source tool we have developed in Outburn. So I'm Daniel Mechanik. It's actually Mechanik, but you can call me a mechanic. Founder and CTO at Outburn Ltd. I'm a data and integration architect. I have some experience in health tech. I consider myself a FHIR evangelist. And let's dive in. Most importantly, this is Vicky, and yes, she's not only very beautiful, she's also extremely smart, and yeah, that was the top priority, and now let's go on. So the challenge is conversion of data to FHIR, which is not as straightforward as it should be, and it's not about the data structure. I mean, the structure of FHIR might be by itself a little bit complex, but that's the easy part. The real challenge is, first of all, in the content, the correct use of URIs, understanding profiles, bindings, slices, terminology conversions. Each use case and profile has a lot of fixed values. So you find yourself hard code them in whatever tool you're using. If you have a resource repository to work with and you don't want to destroy your data, then probably you're going to need to query that server before you decide what to do. That affects the conversion. The same source record will have different results if it's a different FHIR server, and even if it's the same server, if it's at different points in time. So it's not a stateless process, so a converter cannot be stateless. It needs to take into account the state of the data on the server. So existing tools like plugins and SDKs, they are usually platform or language specific, so they are not reusable across organizations. Even if we are implementing exactly the same use case, they usually create vendor lock-in. Replacing the tools will mean that we have to rewrite everything. And the audience is a programmer, so most of you, I think, are programmers. This is what it feels like here in DevDays, but in the real world, the programmers are not probably ones that have been to DevDays. They are not FHIR specialists. So you might have good data experts and FHIR experts that are probably bad programmers or not programmers at all. And you will have very good programmers that are not data experts and not FHIR experts. And you don't want to have them make FHIR-related decisions, usually. And they are expensive, yeah. So, and validation. The extent of validation in the existing tools, it's usually limited. It varies between them. Usually it's just the base. Code validation, maybe. Cardinality, usually only base, not slices, not profiles. And you usually realize you have problems in the data only in production, which leads to poor data quality. So conformance to profiles is entirely up to the implementer. If you know how to read the profile and he knows how to copy-paste correctly, then it might be conformant, but a lot of the times that doesn't happen. And it is a process which is prone to errors, and it is very hard to maintain if you have hard-coded URIs all over your code, and you need to change a URI or something like that, replace the URI of an extension, that might be very painful. Also, from the other side, existing FHIR data is not very trivial to work with. Sometimes very simple questions require chains of API calls. You need to extract data from FHIR resources with some expertise. It's not very trivial for anyone. And legacy systems may not be able to work directly with the FHIR APIs or with the resources. And resolving references is usually part of the picture. So it's a concept I use, reverse facade. This is something we find that could be very useful, to have a reverse facade for those systems to continue seeing the data as they are used to, and not really needing to dive into being FHIR experts. And also, not all FHIR servers are the same. So if you want to be interoperable as a client, you better rely only on the widely supported capabilities, and you need to compensate for that somehow. I don't know of a vendor-agnostic method to implement the missing capabilities. So if you chose a server, you need to implement some capability that doesn't come out of the box that would be specific to that server and not interoperable. Operation definitions, search parameters, they are not executable, they are just definitions. So in the end, you need to code it into the product. FHIR to FHIR conversions, which is also something we see the need for. For example, transforming a questionnaire response into observations, moving from FHIR version A to FHIR version B, from different profiles, and patch, which is something that might become very complex when you want to add data to existing resources. And as far as I know, the existing mechanisms are not perfect for that. So the vision is to have a uniform method for FHIR transformations that is production ready and performant, easy to author and maintain even for non-programmers. It should be platform agnostic, declarative, so we can focus on what we want to do and not how. And we need to maximize the use of FHIR assets, like profiles, supporting it out of the box, and allow the sharing and reuse of our mappings through structure maps, concept maps, FHIR resources. And it should be extensible and modular, and it should be open source. So I skipped one important thing. You should call the transformation using the RESTful API. This is a concept that is inspired by the FHIR mapping language, but we ruled out the FHIR mapping language as a solution for that challenge because we don't feel it's production ready. It feels more like an academic experiment. The function library is quite limited, no really supporting tools except for the Java validator. It's not easy to author. The syntax is kind of hard to learn. It's not declarative, it's more procedural in its nature. It does not maximize the use of FHIR profiles. I mean, I cannot assign a value into a slice, and I still need to put all those fixed values in the map. And also not very extensible. Another option we ruled out is the FHIR shorthand, which is also something we were inspired by, because it does let you create instances of profiles and it will put all the fixed values for you, but it is not built for production. It is built for profiling. I mean, I meant here only like static values can be used. You need to put all the values inside the map, so it's not a real solution, but it's a good direction. So introducing FUME, the FHIR-utilized mapping engine. So it's essentially a converter API factory. We took the FHIR shorthand language as an inspiration, and we added the JSONada. It's an IBM's library, open source library for JSON data extraction and transformation, and we combined them. So now you can use that to create instances of profiles. You can assign values straight into slices, extensions, whatever. It validates on the go. This is in progress. I mean, the validation is, it is not yet a full FHIR validator, but it's gonna be. You can do inline FHIR API calls, so you can know what's the state of the resources on the server and make decisions on the go, convert terminologies using the convert function. The mappings are saved as structure maps, so you can share them and reuse them. And we provide native support for JSON, CSV, and HL7 v2. And since it's extensible, I will show you later that one implementer added already the support for XML, and I'm waiting for his PR to implement that into the library. It is easily extended with additional functionalities. Any JavaScript function that you may have, you can add it. So those are the links. You invoke the transformation using an API. And let's see some examples. So I have this source. It has a patient MRN, a doctor ID, a date, a systolic, and a diastolic value. I need to be conformant to the blood pressure profile, which is inheriting from the vital signs profile. So this is how the map would look like. Instance of BP, the ID of the profile. It could be the URL also. I put the final in the status. Effective date time equals the name of the field from the source. Subject reference uses this literal function. This translates a FHIR search, like a conditional reference, into a literal reference. So I'm looking for the patient with that MRN, and same for the performer. And then the component slice systolic BP, I just put the value systolic into that one and diastolic into the other one. I also don't need to worry about the value quantity since the profile already defined it for a single data type. So the result, I split it because it's very big. So you can see a lot of data has been put there for me. The category from the parent profile, the meta profile, the code, and then we have the component with the code and the value quantity with the system and the code and the unit and the value from my source. And of course, you can see the references that have been converted to literal references. Another example, we have a status active, an SSN identifier, a first name, last name, birth date, and sex with this code F. So you can see here, first of all, you can, of course, use comments inside the map. The first thing I did here, defined an internal function to transform the date format. And then instance of patient, identifier. You can see the system, just like in FHIR shorthand, uses an alias. You can define global aliases. So that would become the URI for SSN. Active, you can see a Boolean logic here. If the status equals active, that would be true. Otherwise, it would be false. Name given and family. I don't care that given is an array. It will do it for me. And calling that function that I defined to transform the date format. And you can see an example of a translate. I'm translating the F through a concept map whose ID is gender. And this is what I get. So it's a patient. It has the system of the SSN with a value. Active is a Boolean true. The given name is inside the array. The family name is just a string. Birth date has been transformed to the correct format. And the gender is female. Another source we have here. This is an example for string manipulations. So this time, this is an IL core patient profile. So I'm using the first row is a slice for the national identifier, and we need to pad that number with zeros, so you have the pad function. The name, I put concatenation here, example of concatenation of strings. On the gender, I put an extension. This is the syntax to put an extension. You don't need to worry about the URL. It's just the ID of the data absent reason. Address, this is an example of context usage. I take the context of the source object address, and then inside the address, I have that context, so I can just use the names of the fields inside the address in the source. Another extension on the city, which is a primitive, and phones, which is an array. Also, when I use that as a context, it just injects it into the array. So again, this is very long. I will go through it. So the identifier, obviously, you can see that the slice has a fixed value for the system, and we have that. The name has been concatenated. This trick in the JSON format, when you need to put an underscore, it has been done for you. And let's go on. The complex extension for latitude and longitude. Again, the city with an underscore because it's a primitive and we have an extension on that. And here's the array of the telecom. So as many as we have in the source, this is what we get in the target. Reverse facade example. Okay, so I have a system that wants to get practitioner information using the license number. So this is how the map would look like. I do a search, and then I take the first entry. This is my decision here. I can do other stuff, and just take to these proprietary field names. I take whatever information I want from that resource, and this is what I get. So the system can continue to work with its own interfaces, even though it's a FHIR server. So I guess I will skip the examples. You can look at them later. Some examples of large-scale real-life test cases. The Ministry of Health Israel is using it to populate their national FHIR server with public health data, and they extended it with support for XML. Rambam Medical Center populating FHIR server from their proprietary EMR data. They have defined their own profiles for that, and Laniado Medical Center is doing the same. Reverse facade implementations, I know of a few. FHIR Interceptor is also something that people play with to use that mapping language to create interceptors that add capabilities. So this is an option to create operation definitions that are shareable. And data quality assurance, we know of a guy that is periodically fetching bulks of data using that mapping language and checks the data according to rules. So that's the most important thing. This is encouraging organizations to create their own profiles, because that way, for all of their URIs and stuff like that, they have a central place where they manage it, which is the profile, and the mappings themselves only deal with the data, the dynamic data. All the static stuff are in the profiles, and this is what I think is a very, very good practice, and it is improving data quality. So I think we're out of time. That's time for question and answers. Yeah, okay, so you'll take a look at it later. Yes, Diego?
I have 25 questions.
You only get one.
No.
Yeah, one. Diego, otherwise.
Have you thought about a Visual Studio Code extension?
Yes, only thought. Haven't done it yet. On the roadmap.
This might be a broader question for anyone. Is experience on doing the institution of your organization to figure out those mappings? Like, who decides that? Like, as a developer, I can go through and make my best guess, but I want input from my customers, and I want some sort of system for an internal team task force. So any recommendations for that is appreciated.
I'm not sure I understood the question, but I will try to answer what I did.
We have an internal team that will do the mappings, but we need some sort of business requirements from multiple different customers. If anyone has some sort of structure for a task force or a process, I would like to lessons learned from that.
So what we see happening is that the business analysts take responsibility for the logic, for the mappings, for the profilings, and they just tell the developers, listen, for this source, call this API, and that's it. So there's like the responsibility is split. The developers are just taking data from here, throwing it into the API, taking the result, putting it in the FHIR server, and they don't deal with the logics between. And the business analysts and the experts in the data, they take responsibility to update the mappings when they need to. And we find that it's also easier to debug because they actually understand what's happening, and the developers usually less.
Is the workflow any different with gigabytes of data, or would you still use the REST API?
Yes, it would, since it is through a REST API, it would be beneficial to not throw gigabytes of data in a single interaction, but split it. You can do it if it's a CSV, just take it like 1,000 rows or 100,000 rows at a time. And it depends especially on the infrastructure. If the server is strong enough, it will handle whatever you want. But you should remember that it is over HTTP.
Hi, does the tool handle like the connection information to the servers, or is that kind of an external concern?
So for now, you have a configuration for the connection for a single server. So you configure all of the connection information, and that is the server that it works against. And you are not exposed to this information from the API, except for if you do a search, you will see in the full URL the address of that server.
Last question.
I have a lot of questions, so maybe I'll just skip them all and say,
You can catch me later.
can I spoil your social event with some questions later on?
Sure.
All right.
All right, thanks everyone. We'll be
Thank
back
you.
in 5 minutes with the next presentation.
Thank you.